Please go ahead.
Okay, thank you, Firdos, and the organizers, especially Vivekananda Global University, Association of Universities, and Jindal School of Global South, and Jammu and Kashmir Economic Association. And first of all, I would like to extend my thanks. You have associated me for this important event, uh, which is being conducted for the budding social scientist. And a very good evening, uh, everyone present in this online workshop on research analytics in social sciences. For sure, many of you be bit excited to learn the use of econometric methods for social sciences, especially use of Gretl software in shaping your understanding of quantitative analysis. Presently, when we see the econometrics, it is being used by not only by economists, business analysts, or financial experts, but many of the social scientists, largely in global north. From all the domains, whether it is sociology, political scientist, or geography. Many of the social scientists are using econometrics. And it is my pleasure to introduce well-known econometrician, Professor Bhagirath Varia. And he has been associating with us. We have learned from him during the last workshop on econometrics particular, and who will guide us through this complex and vital subject and the use of Gretl software. And now it is my pleasure to introduce Professor Bhagirath. Here is about us about Professor Bhagirath. He is currently serving as an assistant professor at the Department of Banking and Insurance and Faculty of Commerce, the Maharaja Sayajirao University, Baroda, Gujarat. He is a doctorate in business economics and has deep expertise in econometric modeling and data analysis. His research work focus on policy-driven analysis for critical economic issues. He has high-quality research publication, particularly in Scopus ABDC indexed journals, and three books with the Routledge and World Scientific. He is the founder of educational initiative called Cafe Economics, and he continues to impart training on economics, statistics, econometrics in India and in abroad, and to all of us also. And it's a rare opportunity for us to have someone uh, 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 like him with us today to share insights that will enrich our further learning of econometric methods and while using Gretl software. And in last, I think it's a uh, it's a seventh session of this workshop. I think I don't need to remind you to that you have to keep your mic mute during this lecture. But if anybody among you find that there is something pertinent to ask during the lecture, and you could drop your query in the chat box. And in the end, we will get a chance to ask your queries directly from Professor Varia. And now over to Professor Varia. Sir, please, you can start.
Thank you so much, uh, Dr. Jaskaran, and I hope I am clearly visible as well as audible.
Yeah, sir. Yes.
Great, great. So nice to see you, and so nice to be connecting with all of you again. And we met earlier also, as many of you might remember. I think
Yes.
in the first session itself, and now we
Yes.
are on the next session. So let us start with our work. Let's get down to business. And before we do that, I'll just request the IT team to please make me the co-host so I can share my screen. IT team, please make me the co-host.
Done, sir.
Thank you. So our journey begins with a small overview of. Let me just first share the main screen, and I prepared a very nice first page to show you. And today I'm going to adopt a very different strategy. I mean, some of you who have attended my sessions earlier must be knowing that I tend to discuss the theoretical issues first, and then I show you the hands-on background. But given the nature of the workshop, the profile of the participants, and the kind of discourse that is going on, I felt it would be much better to directly work on the Gretl ecosystem and thereby practically learn various issues in econometrics. And instead of going into the theoretical properties of econometric estimators, which is the heart of the theory of econometrics, it is better we go on to dealing with data directly. And so the approach I am going to have is quite different today. A lot of hands-on and very less direct theory discussion. Of course, we will discuss theory. Of course, we will discuss the fundamental concepts, but at the same time, we will learn things in a more nuanced, practice-oriented approach. Before I start that, I have brought two important things for you. This you might be able to see. This is a very nice book. Because of the background, I'm not able to show you. I'll share the PDF of those books. You do read them. They will be really helpful. I'll just show you the brief overview of what I really wanted to discuss today and how I wanted to discuss today. You can have a feel of the intensity of today's session. And theory is the heart of econometrics. If you don't understand econometric theory, it is very difficult to understand the way in which econometrics deals with data. Statistics is something you have studied till now, correct? If I am not wrong, you have studied statistics in this workshop till now, and these are the major topics in statistics that you should know, which include first descriptive statistics, very important, include correlation analysis, it includes graphing of data, it includes a very important part known as hypothesis testing. We deliberately did not want to have a separate session on hypothesis testing for the simple reason that it would require multiple sessions to be able to explain it. And we have seen workshops where they teach hypothesis testing in a single session, and that's not correct because it requires you to understand certain topics, certain ideas very, very carefully. And during this session, you will be able to understand hypothesis tests. I mean, the idea behind hypothesis testing is quite simple. If you understand the crux, you have a population that is something that you are interested in. It can be a lot of companies, it can be the entire country, it can be the global economy, it can be your own firm or company where you are working as an HR manager, for example. You are interested in the employees of your company, or you are working in or you are running a business and you are interested in your customers. All those people or institutions or entities which are of your interest for analyzing, for solving some problem, that becomes your population. Okay. And naturally, you won't be able to collect data on the entire population. So what you will do is you will collect data on a random and representative sample. These are two very important concepts in econometrics: random and representative sample. And there's always a trade-off between them. The more you try to randomize, the danger is lesser representative your sample may become. The more representative you try to make it, the more non-randomness you have to permit in your sample construction. So you take data on sample out of that population, ideally randomly, and then you play with that sample data, you analyze it, you run it through trial and errors, and you find certain things, you make some calculations, you use some formula, maybe a mean. I mean, you studied about descriptive statistics, so arithmetic mean, you estimate an arithmetic mean, but it is about a sample, it's not about the population. So how do you make comment from arithmetic mean value, average value of a sample and draw conclusion about the whole population. That is, you had 10,000 customers whom you wanted to analyze. You randomly selected 100 customers because it was not practical for you to go and approach everybody. You analyze those random sample of 100 customers, find out average satisfaction level of those customers, and let's say it is very high, but does it mean all 10,000 customers would also feel the same? You can know that by using hypothesis testing. Jumping from sample result to conclusion about a population is known as hypothesis testing. When you do it for, let's say, a single mean value, for example, you can use uh, uh, when you are talking about mean value of the population. So you are not in hypothesis testing, you always are interested in population mean value or population values. But what you have, sample calculation. So in that case, t-test is a well-known hypothesis testing that is used. Suppose you are not interested in mean, but the variance, the spread of data. So you want to study or know something about whether if your sample is having lot of spread, that is lot of variation in how customers feel about your company. Okay, lot of wide variation. Some are very happy, some are very sad with your company, some are angry. Is that also true for all 10,000 customers? If you want to answer that question, you go for chi-square test on the variance. So these are various ways. I'll be sharing these books. Stock and Watson is a wonderful book. It has a chapter 3, whole chapter on review of statistics. Read that chapter well, and I'm sure you will be all right with it. And naturally, we will have a separate workshop on these topics also very much later on. Fine. So in econometrics, one idea is that the idea of having econometrics, why do we do econometrics? It is that because we cannot conduct experiments in social sciences, and econometrics is for social sciences. Let me clarify this. We should not have any wrong idea that econometrics, the word econometrics means it is for economics. Of course, it were the economists, the great economists of the 30s and 40s, like Jan Tinbergen, Keynes also, who Fisher, who contributed a lot to developing the science of econometrics. But the idea of econometrics is to be able to answer questions which are very common in social sciences. That can be in HR, that can be in finance, accounting, business studies. So the idea is we can't conduct experiments in social sciences, particularly large scale experiments. So there are small scale experiments in management sciences. I've seen many management journals like marketing journals. They go for randomized control trials on customers. I've seen economists doing that, but those samples are quite small. I mean, you can't really draw state level or national level or global level conclusions out of them. So in order to experiment with data, you have no direct control over it. So how do you create that control over data? If I were an experimenter, I would have a laboratory. I would be able to control all the conditions of my lab and then see whether X causes Y or not. Whether X causes Y or not. It would be crystal clear to me under laboratory conditions whether X causes Y or not. Why? Because I have complete control over Z, A, B, C, D, everything else that could interfere with my experiment. I would have complete control in my laboratory, if not complete, a very large amount of control. But that's not the case in social sciences. As an HR manager, if you want to see whether a new working hour scheme, like nowadays we have debate on 70 hours and 90 hours. Let's say you decide a new working hour where you work only 4 days a week and 3 days is off. Whether this will be successful or whether it will affect the productivity of your employees positively or not, this is something that you can't really do on everybody together. You can't experiment that, because if you do that and suppose it becomes good but your company doesn't like it due to some other reason, some legal or some other reason, it will be very difficult to go back, isn't it? So in that case, you can take past data, create actual experiments on them, run them in your computer softwares by using good theory, and then draw conclusions from that. That's the idea behind econometrics. That's the idea behind why we do econometrics. All right. So with that, I think we have good amount of fundamental background. Just a moment. Yeah. So what I'll do now is I'll share another screen with all of you. But I have a lot of content ready, but I don't think I will take it. But yeah, this is important to let you know that econometrics starts where statistics ends. If generally you see a statistics book, it would largely discuss about regression at the most. I'm talking about statistics for in social sciences, not pure statistical theory. That goes quite deep, and econometrics also uses that. But applied statistics books, if you see in general, statistics for business, statistics for management, they generally end at regression or ANOVA or ANCOVA or MENCOVA, some variant of regression analysis or compartmentalization of data, of variants basically. So they end there, and they might introduce one or two unique topics like logistic regression or something. It basically, regression is where typical applied practical statistics book ends. That is where econometrics starts. All right, that is exactly where econometrics starts. So that's the idea behind econometrics. We have to have a specific kind of question which are known as causality questions. You know, the first slide that I showed you. If you see my browser, my cursor here, key concepts. First one, dependency. How is Y dependent on X? For example, how is productivity of employees dependent on working hours? All right, that can be a very practical question for a company thinking about changing its working hour policy. Whether working online versus offline improves productivity. So how? So the question would become here: how working online, why will be your uh, uh, here your why will be your productivity or efficiency of employees. How productivity of employees, why, is dependent on working style, whether online or offline. So these are the kind of questions that you try to answer, which are known as causality questions or cause and effect questions. So econometrics deals with cause and effect relationships. Okay, statistics is not very good at cause and effect analysis. So particularly, statistics is not good to answer causality questions for social science data that are not emerging due to some experiments, data that are emerging out of very complex processes about which we do not have any control. So for example, how is the economic condition determined, or whether your area will develop, wherever you are living, city or area or region, whether it will develop or not compared to other areas, or how will the global economy move, or how will your firm or company perform if a bigger giant larger competitor enters into the market. These things are very complicated. Going, lot of things will be going on. You know, a lot of things will be going on. So it would be quite difficult for you to make judgments about it directly, and that is the reason why we in econometrics look at causality questions or cause and effect questions. Fine. So this is the idea behind econometrics. Traditionally, the definition of econometrics is using economics and that economics can be replaced by any subject in social sciences, management or HR or finance or marketing or business studies or accounting or finance or public administration or sociology, anything. So combining a subject, a social science subject, statistics and mathematics, three components together to answer questions of cause and effect relationships. That is, how Y is caused by X. In other words, how X causes Y. Answering those causality kind of questions in social sciences using three disciplines: your subject, HR, marketing, economics, whatever it is, mathematics and statistics. Combining them, you create what is known as econometrics. So econometrics starts with regression analysis, and that is why we had regression before this session. And we are going to learn again about regression, but in a different tone and in a different manner. So let me now start with our session on dealing with doing econometrics, that is conducting econometric analysis using Gretl or exploring different econometric methods. Fine. So what I'll do is I'll stop sharing this screen and I'll start sharing another screen with all of you. And I now request all of you to be ready with the data files that I had given you. If you remember, I had given you data files earlier. You can keep those data files ready. There are two data files, session dataset 1, dataset 2. Dataset 1 is to be used. And what I'm going to do is I'm going to show you how we do, practically how we do econometrics and what are different methods. And methods differ based on the type of data you have. All right. So I have given you two files. The first file, dataset 1, is a cross-sectional data. There is no time element in the data. The data was recorded at a point in time. So let's say right now, I analyze all the participants in this workshop. What are you, where are you located right now? That's one data point. So if I analyze your locations as of now, it's cross-sectional. There is no time element in this. So the variation in the data, somebody may be located outside India, somebody may be located in India, some may be in North India, some may be in South, some may be in Northeast, East or West. Your locations, your diversity, variation will not be because of time, because there is no time element I'm allowing. It is as of now. But if we keep recording this for all 10 days of the workshop, then it becomes for a particular person. Okay. Now there are a lot of people here in cross-sectional data. Each of you is a cross-sectional unit, one cross-sectional unit. So let's say there are, as of now, 122 participants live. Each of 122 participant, each one is one cross-sectional unit. Fair enough? Now, what I do is I take one cross-sectional unit. Let's say randomly I'll see the participants. There is Abhirup Singh. I'll take Abhirup Singh as of now, and for every day across all 10 days, I will record his location, where is he located. Now that becomes time series data. So you take one cross-sectional unit out of the cross-sectional data and record their behavior or data over time. It can be over days, over weeks, over months, over years, over decades, over centuries, depends on your purpose. That is known as time series data. So I have shared two kinds of files with you. Dataset 1 is cross-sectional data. It's about 6,000 plus students, actual data set conducted in US, about 6,000 students. Their exam performance, exam score is studied with reference to various factors like attendance, sleep, how many hours they study, what was their previous exam score. Okay, so it's very intuitive to understand. And second is time series data, which I have taken from my earlier book, which was published with Routledge. From there, I have taken that data set because I have used a lot of data there. So that's time series data. So we will deal with both kinds of data quickly, and I'll give a very good overview of how to handle the data when you have it, depending on the kind of data. So the title is Econometric Methods for Social Sciences. So methods are different depending on the kind of data you have. There is third kind of data also possible, where you take all the cross-sectional units, let's say all 122 participants which are live right now, and I record their location for all 10 days. Instead of one cross-sectional unit, I have more than one cross-sectional unit. In this case, I have 122 cross-sectional units. Now there are 125 participants, so 125 cross-sectional units. Now I record their location for all 10 days. So for each of you, there is time series data. Combine the time series data for each of you, we have a big panel data. So where there are 10 time elements, 10 days, and correct. So yeah, that is correct. 10 days and then 125 cross-sectional units. That's panel data. But I have not included a data set of that because panel data itself is a very demanding task. and simply showing it mechanically would not do well. We can have a separate workshop on cross-sectional econometrics, time series econometrics, and panel econometrics. Okay, so I'll be dealing with cross-sectional and time series data with you. So we'll go on to, firstly, I'll show you the screen of Gretl, how to go about downloading it. So you can Google Gretl download, and I hope you all downloaded the Gretl and put it there in your computers. I'm hoping so. So you can download Gretl like this. Just a moment, I'll have some water. I came quite rushing, that is why I told you I'll be a little late, but fortunately I came on time. So we were not very late. So you can just Google download Gretl or Gretl download, and you will get the first result, which is of Gretl official website. The full form of Gretl is GNU Regression, Econometrics, and Time Series Library. It's an open source, completely free of cost econometric technology, which allows you to conduct from most basic to most advanced econometric and statistical analysis without asking you to pay a single penny. That's it. So the first major advantage of Gretl is it will give you the latest tools, latest add-ons to analyze more advanced kinds of data or used more advanced methods, and it will not charge anything from you. Secondly, it is very user friendly. As we will see right now, it will be very easy to deal with this. Dealing with Gretl becomes quite easy because of its overall ecosystem. And lastly, Gretl is capable of extracting data from well-known textbooks like Ramanathan's book, Stock and Watson's book. So those data sets are inbuilt, available through Gretl server. You can get those data and do a lot of practice work. So these are the things about Gretl. And here on this screen that you are able to see right now, there is a self-installer option, 64.exe, Gretl 2024D 64.exe. If you click that, it will ask you to download. I won't be doing that. I already have it in my computer. But if you click that, it will ask you to download. Then open that exe file and go ahead. Keep putting next. No need to choose anything anywhere. It is not going to ask you for any key or any license or anything. Keep putting next. Let it get installed. Once it is installed, I'm sure you'll be able to do it. If somebody faces any problem after the session, contact me. But I'm sure 99.99% of you will not face any problem. Okay, it's a very simple download and installation procedure. Keep pressing next. Don't make any changes. It will get done. Once it is done, okay, now I'll share with you Gretl screen itself, how Gretl looks. Okay, that is what I'll share with you. It's taking a little time. Yeah, it is ready. So once you download and install Gretl successfully, Gretl icon will be available on your desktops. And once you press that icon, it will open Gretl. And this is how Gretl would look. Just yeah. Now I'm going to share the screen with you, and I've just shared it. I think within 5-10 seconds you should be able to see. Now you should be able to see the screen. If somebody is not able to see, wait for 5-10 seconds. Due to internet issues at your end, it may take time at my end. At my end, it is absolutely fine. This is how Gretl looks. Very nice, neat, clean, simple ecosystem. Not much to worry about, and easy to understand, isn't it? Quite easy to understand. And if you look at this screen, there are at the top, you will see all major typical options that are there in various softwares. File option, where you can do various works such as open various data sets, create a new data set from scratch. But I would suggest never to do that. Always go for Excel. That is why I shared Excel files with you. and you can store your script files, session files, and Gretl also has the capability of using command language, but its overall basic menu is so user friendly. You won't need to use command language. I mean, nothing great comes out by using command language versus clicking options. The algorithm is going to remain the same. If you run OLS, or if you run um, let's say instrumental variable regression, it's going to be the same whether you use command language or you click on button. So in the end, that's not your priority, and that should not be your priority. So this is the Gretl ecosystem, and there are two files that I have given you. One is the Excel file of cross-sectional data. Another is for time series data. What I'll do is I'll open those files also for you, and I'll quickly show you those Excel files so that you have some feel of what we are going to discuss. And let me share that Excel screen with you now. Quickly, I'll just give you a quick overview of what that data is, isn't it? So we should not feel confused or alien to our data. We should be comfortable with our data. So this is the Excel screen that I have shared with you, and this is the first data set file. And there is one sheet. In case I have given you a file where there are two sheets, go on the sheet where it is written quant, QUANT. I'm sure I have given you the file where there is only one sheet in this file. So quant, the name of the sheet should have the word QUANT, quant, at the end. This shows data of 6,607 students, as you can see on your screen. More than 6,500 students, more than 6,600 students on various aspects, such as primarily we are interested in their exam scores. So school is interested to know how can they improve the exam scores of their performance of their students. So their exam scores. Then what are they linking exam scores with? Very common sense based variables. If you see, you'll be able to get hold. Think about yourself as a school student. You know how many hours you study. Then what is your attendance? Whether you exam score is measured out of 100, aggregate average exam score in all subjects. Hours studied is measured in terms of number of hours studied per week, not per day, per week. Nobody can study, for example, 23 hours a week, day. That is foolish. Then attendance, out of total lectures in the school, classes in the school, how many percentage of classes were attended? So this person attended 84% of the classes. Sleep hours is measured in daily terms. Per day, how much is the student sleeping? Previous score is the previous semester or previous year's average score. So if those who were scoring high earlier, are they also scoring better right now? That can be one hypothesis you can test here. Then whether they are giving, how many tutoring sessions are they having, extra sessions over and above their classes with teachers personally, they go and personally discuss. So that is written here. And finally, how many hours of physical activity are they conducting per day? Okay, every day in school or at home or whatever it is. So this is the data set. Now what we want to do is we want to feed this data into Gretl. So again, I'll go back to Gretl screen. I'll share the Gretl screen with you all. Yeah, it has been shared. Wait for 2, 3 or 5 seconds. You should be able to see. And in Gretl screen, now I want that Excel file to come inside the Gretl ecosystem. And in Gretl, we have the first, on the top, we have various options like file, tools. If you see file and tools, they are enabled, even though we have not put any data. But data, view, add, sample, variable, model, these options are disabled. Unless you put data, import data in Gretl ecosystem, it won't enable these options for you. At the bottom also, you have various options. If you see my mouse, if you are able to see my cursor, at the bottom also you have various options like launching a calculator or taking a session icon view. That is, if you want to see what sessions you have conducted and what all you have saved, models that you have saved, correlation analysis that you have saved, all those things can come here. Then there are command references. If you want to use command language, this is the right way. Various graphs can be made from this, but no need to get into all this. You will see everything is available once data is fed into it. So we go to the option file. All right, we go to the option file, and we go to the option open, okay, which you are able to see on your screen. File, open, and we go on the option user file. In user file, I will find out that folder where I have stored this particular data. Okay, the data that I want to load into Gretl. I'll go to that folder. Once I go to that folder, nothing will be visible. As you can see, right now it is showing blank. So what I need to do on the bottom right, I need to click the format of file for Gretl is GDT. Okay, GDT is the format of Gretl file. So I'll have to go on the bottom by using my scroller on the mouse and go on the bottom one, all files. Once I click all files, everything is visible. All kind of information in that folder is visible, and I will choose the first file, the dataset1 file, which I want to use right now. I'll choose that, and I will press the button OK or open on the bottom right side. Okay, the option open. Once I do that, Gretl will ask me, where do you want to start importing data? From column 1 and row 1, or let's say from column 3, row 1, or column 2, row 7. I mean, it depends on you. How do you want to, from where do you want to start the data? Generally, it is the way you have created your Excel. Generally, you will start from first column, first row. You will take the entire Excel sheet into your Gretl ecosystem. Yeah, somebody is saying, could you be a little bit slow? Fine, sure, I'll do that. I'll do that. So let me again repeat this process quickly. We go to the option file. The Excel file is, I have given you in the WhatsApp group in Excel file, both. So you have to download from there and put it in your PC. I shared it long time back with you, 1 or 2. You need to download from there and store it in your computer. And you cannot see that because of that option. You have to, I'll show you what to do. So go to the option file, go to the option open data, press on user file, and there you choose, you go to that folder where you have stored the file. Generally, in your folder, you won't see anything at the first instance. You may not see anything. Here, you have to go on the bottom right side and click on that data file option. Okay, click on that data file option on the bottom right. After going to the folder where you have put your Excel file, go on the bottom, last one. Use your mouse scroller or down key on your keyboard. Go on the last one, all files. Once you click on all files, you will be able to see all the files you have put there, including the Excel files. So I'll take the first one, 280125 dataset 1, which I have already given to all of you, and I'll press open. Once I press open, it will ask me from where do I want to start importing it. Generally, it is from column 1, row 1. You want the entire data, and you should create your Excel sheets in that manner. That entire Excel sheet can be used in Gretl. Sometimes you may not want initial 5 observations or first 2 columns. It depends. You may not want it, so it's up to you. Then you can go on column 2, for example. Start from column 2, or you want all the columns but don't want to start from all the rows. You want it to start from 5th row. Up to you. I'm going to keep it 1 1. Simple. 1 1, column 1, row 1, and I press the button OK. Once I press OK, Gretl will take some moment to process the data. Now, if you see the screen, Gretl has imported the data successfully, but it is asking something. It is asking that according to Gretl, it is a cross-sectional data. It has understood it looking at the data, but it may be wrong. So it is asking you, should I change how I have interpreted the data, or is my interpretation correct? So the interpretation of Gretl is the imported data have been interpreted as undated, that is cross-sectional data, which is correct. Do you want to give it a different interpretation, time series or panel? If it is correct, no need to say yes, go for the option no. Okay, go for the option no. So the data is loaded into Gretl. And now what we want to do is, we want to understand this data and see what all can we do in this data set using Gretl. Correct? That's what we want to analyze now. So what I'll do with this data, and if those of you who already opened the data set at your end, what we will like to do now is, I will take you through various steps of how to deal with such kind of data. firstly, you should be clear about your data set. It is about exam scores, and you want to see what factors affect exam scores of your school students. There are 6,000 plus observations. If you want to know the exact number of observations, it is written on the bottom side of Gretl screen. 6,607 observations are there. Okay, and it is also written as undated. In other words, cross section. So Gretl uses the word undated for cross sectional data. That is, there is no time element in this. Now, what we want to see is we imported the data. We saw the data in Excel. We got the data into our ecosystem of Gretl. We got an idea of Gretl ecosystem. Let us spend a little bit more time. Now the option data, view, add, sample, all these are enabled. So now Gretl will allow you to start using them. And what I wish to do here is I want to look at the sample option. Gretl gives you the ability to increase or decrease your sample size. Okay, it depends on you. It depends on you. What kind of sample size do you want from Gretl? I'll repeat it, but you can also look at the recording. The reason being, if I repeat everything one by one, I won't be able to complete the session because it's a very long thing that I have planned for all of you. So I want to show you maximum things. Don't worry if there is some problem. After the session, you get back to me. I will help you. But I hope most of you are able to follow. At the end, I'll try to quickly go through everything once more. All right. So if you look at the screen, this sample option here, it allows you to restrict your sample. Recording are being shared on all on the official website or YouTube channel of JKEA. My first session has just now been shared, recently been shared in WhatsApp group. You can have a look at it. It will be given to you. Okay, all recordings will be available. So don't worry. So you go to the option sample, and in the option sample, you can decrease your sample or restrict your sample. Why? For example, you know that in your sample, uh, let's say the first, there are 6,607 students in your sample, but first 100 students were not your students. They were alumni students or past students, and by mistake their data has come. So you can remove them by starting from 101 number observation. You should be able to see that on your screen. What am I doing? Okay, you can start with that 101 observation. So these are all simple things that Gretl allows you to do. There are more unique things. For example, in the option sample, okay, after clicking the option sample, you can go to this option random subsample. So you can create smaller samples out of your existing samples. Okay, smaller samples, and you can randomly create those samples from them. That's also a very good uh, ability that Gretl provides you. Okay, don't mind, I'm having my tea because I'm running around like anything. So excuse me. So Gretl gives you this random subsample option where you can create a small sample out of your main data set and run your analysis on that. Let's say you have data on entire population. Let's say you have only 500 or 1,000 employees in your company, and you have data on all your employees, and you collect that entire data and feed it into Gretl. But you don't want to analyze everybody. You want to analyze and see how uh, a particular variable, let's say sleeping hours, would affect the performance of your employees. Just giving you a very wild example. Okay, no company analyzes these kind of things. Give me a wild example. You can create a subsample. So if you create on random subsample, you can draw a random sample of any size. Let's say 100 or let's say 500. Okay, from that data set. Okay, maximum is 6606 because that is the total maximum number of observations you have. So you can create your sample out of it of specific size, which is randomly created by Gretl. Okay, maybe you have data on all employees, but your analysis work is done by a third party company. Now you may not want to share data on all your employees there. So you take a good sample, let's say of 250 size or let's say of 500 size, and you once you press OK, it will drop 6,107 observations and only retain 500 observations. So now if you see the bottom of Gretl main screen workstation, the full range is 6607, but now currently the data set is only for 500 students, or let's say it is employee data. So now you can only share this analysis or this data set with a third party company which wants to use this data. So these are some practical way in which you can use Gretl. Now you don't want to do that, you want to go back to the full sample. So go to the option sample, okay, click on the option sample, and second option, restore full range. Sample, restore full range. Once you do that, again your sample has come back to the original one, okay, that is 6607 students. What all can you do now? What we will do is, we'll now look at how to, what are data related options we have. So go to the option data, and if you just have a look at it, you can add more observations. Let's say there are 2-3 students whose data was not recorded, so you can go to this option data and then click on add observations, and then whatever variable you have selected, it will add extra data points there. So if you want to add it for all variables, in every variable you will have to manually click and then go to the option add data and then add observation. This would not be a problem. There is another trick here. Go to your Excel, update everything, and suppose I make some change in my Excel file, which we have already put into Gretl. But let us say there were 5 students whose data I forgot to record. So I add data of those 5 students on exam score, hours studied, attendance, sleep hours, previous score, tutoring session, physical activity in my Excel file. Now that means instead of 6607, I have added, let's say, information on 3 more students. So it will be 6700. 6610, sorry, it will be 6610. 3 more observations have been added. So I don't need to cancel everything and restart everything. I can simply go to the option file. Instead of open, I'll go to the option append data. Instead of option open, I'll go to the option append data. And once I click append, I'll again select that same Excel file where I have added new information, new data. And once I press open, okay, I'm not pressing it right now, there is no need. Once I press open, it will update and automatically include that extra data. But the condition is the original data file should not be changed. Only you can add information to it. If suppose you added something in between somewhere, it will not be able to catch it. But if you do it at the last, at the end, it will be able to catch it for sure. So these are some basic functionalities of Gretl. Let's go on to a very important thing that you have learned about descriptive statistics. Okay, you can run descriptive statistics here also. For that, you have to go to the option view. Okay, for descriptive statistics, you go to the option view, and then you go to the option fourth one, summary statistics, option view, and the fourth one, summary statistics. Okay, summary statistics, and you can select all the variables you want. The first one is just an identification variable, a roll number. You don't need to include that. From exam score till physical activity, all variables are included. Okay, I press that green button after selecting them here, and I press the green button, then I press OK. It will ask me 2 options. Do you want to see the main statistics, mean, minimum value, maximum value, standard deviation, the few major descriptive statistics, or you want to see the full statistics? Generally, you go for the option full, press OK, and here your descriptive statistics is presented, where kurtosis and maximum value, minimum value, the interquartile range, if there are any missing observations, skewness, coefficient of variation, everything is presented to you by Gretl. And you can then press Control A. Typically, we press Control A to copy or paste something from somewhere. Control A, then you can right click with your mouse and you use the option copy. Once you use the option copy, again I will repeat, descriptive statistics are done. Okay, descriptive statistics are done. You press Control A, then you right click, and then you click the option copy. There are 3 options it will ask you. What format do you want to copy in? Generally, I go for RTF, MS Word, because generally we want to take all this to our research paper or our book file or our project report. So it will generally be in Word. So you can go to Word. Some people use LaTeX, so you can click LaTeX option also. Generally, it is word. So you can take the RTF option. All right. So this is how descriptive statistics are done. Now comes the question of correlation. Variables can be correlated with each other. So how do you assess that? And there is one wonderful tool that can we see the result in Gretl? Result of what? Descriptive statistics. It is visible in front of you. Option view, summary statistics. Select all the variables. Press the green button. Press OK. Full statistics.
Excuse me, Professor Baria.
Yeah.
Results are not visible when you
Is
are.
it?
Yeah.
Oh, okay. I got it. So you are able to see the option, but not the results. Correct. I'll share
I
that.
think you didn't click on OK, and that is why it is not visible.
No, it was visible. It was new window is open. Now it is visible.
Yes.
You can see the screen now. Actually, Gretl opens new window for all major kinds of calculation and estimation work. So that's a good alert for me. Every time I do that, I will reshare that screen also. So you can see the results in front of you. In full statistics option, all major descriptive statistics are introduced: skewness, coefficient of variation, excess kurtoses. Generally we talk of kurtoses, but Gretl reports excess kurtoses over and above what should be there for a normal distribution. Then it shows IQ interquartile range, if there are any missing observations. All those things are provided by Gretl to you. And you can then press Control A, and then you can press right click on this if you want to copy paste it, and then press the option copy. Again, Control A, right click, copy. There will be again 3 options. How do you want to copy it? As Word file copy, you want to copy paste it to a Word file, or to as a plain text, or as latex file. Generally it is RTF. That's the major one you should use. Formatting will be very good. So you can copy paste this results into your Word file, say for your research paper or book or your project report, whatever it is. Okay, so I'll again reshare the main Gretl screen with all of you. Fine, I've just shared it. It will be visible in a moment. Yeah. So now what we want to do is we want to see. Now we want to econometrics is so there is one very important thing I wanted to show you. I forgot to show you there. I'll definitely show you. All should use it in your research work, in your papers, in your project reports, in your books if you're writing. We go to the option view correlation matrix. We select all the variables we are interested in. Green button, so right click, and they are there on the right side. Press OK. So this is the correlation matrix option. Again, I will repeat it for you. We go to the option view. Okay. Then we go to the option correlation matrix. And again, it will ask you which variables you want to bring into correlation matrix, whose correlations you want to investigate. We select all the variables that we are interested in, press the add button or the green button. They come on the right side. So now Gretl will work with those variables. On the bottom right, press OK. And once you press OK, the results are put, but it is, I'll again share the result screen with you all, because Gretl opens a new window every time. Yeah, so I've shared the result screen in front of you for correlation. And yeah, so now you can see correlation here, and there is a hypothesis test done for correlation values, but you don't get into this. As far as hypothesis testing for each correlation coefficient, so that is if you want to test the null hypothesis, whether each and every correlation here you can see the correlation coefficient 0.4455, which is between hours studied, this one hours studied, and here on the right side exam score. So the correlation is positive, and I would say moderate, given it is cross-sectional data. Even 0.4 correlation is quite nice. So there is a positive moderate correlation, I would say. So if you want to test the significance, null hypothesis, that is whether each of this correlation coefficient is statistically significantly different than 0 or not, then EViews is a much better. option there. EViews has that option, and if you remember, Dr. Prashant Vadekar must have discussed with you of correlation analysis in EViews. But there is one thing that EViews does not have, which Gretl is able to provide in correlation analysis, is that in this same window you can see a weird icon on the top, heat map. You can see a weird icon here, the heat map. I'll click that heat map, and once I click that heat map, really a very beautiful window is opened, isn't it? Very beautiful window is opened. I hope you can see the heat map, everyone. Sure, you can see that. I can make it up. So this heat map is a really interesting, and I'll stop and reshare the heat map with all of you, how it looks. In the correlation result window, on the top side, you will have a weird icon, reddish icon. If you take that icon, you will be able to see the heat map option. And once you click on heat map, you will have this heat map in front of you. The redder, the more red the color, the higher the correlation coefficient between them. Naturally, you should ignore the diagonals because they represent the correlation of the variable with itself. Diagonals, exam score with exam score is always going to be 1. Hours studied with hours studied is always going to be 1. Others are more important. Areas which are relatively redder, like the 0.4, 0.6, here also 4, 6, they will always repeat on both sides, correct? Those are really interesting ones. And in your data, it seems that there are this 2, here 2. This 4 are what you should be looking at or concerned with. They could become a source of what is known as, maybe could become a source of multicollinearity. But given that they are quite small, 0.2, 0.2, 0.6 is considerably high for cross-sectional data, for cross-sectional data. So here on the bottom side, you see list of variables. On the left side, you see list of variables, and you can always link each cell. So 0.6, this 0.6 is between here exam score, okay, 0.6, and here attendance. Here there is variable attendance. Here you can see on the bottom side. So that is the correlation. It represents between these 2 variables. So you can present this correlation matrix in your study, in your research work, and you can comment nicely instead of putting the table. Having correlation heat map creates a much more impact and visual appeal. So this is one really interesting thing in Gretl. I'll again reshare the Gretl main screen with you. All right. So now comes the question that we want to answer some practical questions. Cause and effect question. How do factors such as hours studied, attendance, sleep hours, previous score, how do they affect exam score? Okay, that is what we want to analyze. And for this, we use the econometric method known as ordinary least squares, OLS. OLS is whenever we talk about regression, we generally talk about regression. In statistics, regression is regression. But in econometrics, regressions have different forms. So there are different methods of conducting regression analysis. That is regressing x's or y on x. So there are different ways of conducting this regression work. The most popular way is ordinary least square. So in Gretl ecosystem, you go to the option model on the top right side. Before the help option, there is an option called model. Here, model. Right? You click on that option model, and the very first option is ordinary least squares. Okay, which is your regression analysis. And ordinary least square is the foundation of econometric theory. All other options that you see here, instrumental and various other linear models like weighted least square or heteroscedasticity corrected or limited dependent variable, you must have studied about logit models also. Other than logit, in logit also we have 3 options here: binary, ordered, and multinomial. The probit models are there, tobit models are there, even Hackett models are available in Gretl. So many options are there in Gretl. Then there are robust estimations. So if you do believe there is some kind of econometric issue or violation in your data, you can correct for it from day 1, point 1 itself. Then there are non-linear least square, lot of advanced from basic, that is top one, the most fundamental method, ordinary least square, to the most complex methods like state space models are available in Gretl. If you see the 3 options here, univariate, multivariate, panel, they are disabled. because they are specifically for time series and panel data. Only when you have those kind of data, it will enable it. So here we click the option OLS, ordinary least square. Okay, you click the option ordinary least square and a new screen will get opened up. I'll share that screen with you. A new screen will open. Fine, you can, I'm sure you can see the screen now. The new screen that has opened up, it's the screen of specify model. So Gretl is asking you, what model do you want to analyze? By model, we mean what is the y variable in which you are interested and what are the x variables which are going to affect y. How do you know about it? Your theory, literature review, your discussion with your expert. If you're a PhD scholar, discuss with your guide, discuss with other experts in that area who are working in that subject or topic. So you will know all the x variables. Y is what you should know. You cannot go and ask people, what is my y variable? Y is your main topic, whether it's a research paper or a book or a PhD topic or your PhD, master's dissertation, whatever it is. Y should be known to you, that y variable. What are you interested in? Like here it is exam score. What factors can affect exam score is something you need to investigate, read the literature, read good books, talk with experts, talk with your PhD guy, talk with other people working in that area and identify and collect data on them. So here my y variable is exam score. I want to see, as a school administrator, I want to see what factors can improve the scores of my students. Okay, so that my results improve next year and I can get more funding from the government, maybe. That could be my concern practically. So I click exams, I click on exam score and I press this blue button. So it is, once I press it, it is being shown on the dependent variable side. Okay, and now I want all other variables as my x variables. That is, those variables are going to explain how my students' exam performance is occurring. Okay, so what will explain my students' exam performance? Hours studied, attendance, sleep hours, previous score, tutoring session, and physical activity. So I click on the add option on the right side. And once you do this, once your dependent variable here is clear, your regressors or independent variables are clear, and one variable will always be there known as the constant. So never, unless you are having very clear specific reason, do not touch this constant option. Don't remove it, let it be there. If you don't understand why is it there, best is to let it be there. All right, and then you press the option OK. All right, you press the option OK, and new in there I'll answer your question regarding stata. Okay, and a new screen will be opened up and I've shared that screen with you. This is how it looks like. This is how it looks like. About that stata question, stata is heavily dominated by one command language, which takes lot of time, and I believe that is unnecessary time that you are putting in. Secondly, stata is very good for panel econometric models. So if you are going to deal purely with panel models or advanced panel econometric models, I believe stata would be much better. But for time series and cross-sectional data, Gretl is more than enough. You don't need to move to stata. That's my view. Fine. So you see this new screen. Once you press that OK option, this new screen is opened up, and you see the on the top you see which model has been used. So it shows the model number. Generally, we run various iterations. We remove some variables because we in social sciences, for each variable we may have different options available to use. So you may try each of them to see what suits your results the best. So all those things will take time and some iterations will occur. So instead of model 1, you may go up to model 4, 5, 7, and then finally you decide this is the best one that I should keep, given it is theoretically good. It's not about running software and finding which is the best model. It is running the software within a theoretically well-defined idea. There you make some small adjustments. So you see the screen, and on the screen you have model number, which model has been used. It is OLS, ordinary least square. The dependent variable is exam score. Then we have the coefficient value. Okay, the regression coefficients, which you are primarily interested in. We have the standard errors. T ratios are what we would be interested in, and most practical way of interpreting is to look at the p values. Okay, so Gretl puts 3 stars when that particular coefficient, that is this coefficient, is statistically significantly different than the value 0. So null hypothesis for each coefficient, okay, is that its value is 0. The null is 0, but it is rejecting that null because the p-value is very high. 3 star means it is significant at 1% level, 2 star means it is significant at 5% level, and 1 star means it is significant at only 10% level. That's how Gretl reports it. I think most of the softwares do that. And in this, now you have various coefficients, all right, but here there is one coefficient which is negative. So more sleeping hours tend to reduce exam scores. That is what you can interpret. However, it is not statistically significant. So you can't really judge this result as conclusive. So you can perhaps ignore this. As a good researcher, you should not remove this variable just because the result is not looking good. You should report that also. That my hypothesis was sleeping hours will have some impact on exam score, but it is not showing any impact in my study. Let it be known. Problem with us in social sciences is we tend to report all the results which are good. So there is nothing bad. But in pure sciences, you see there are a lot of failures occurring in experiments and they are being reported. And that is also knowledge. Your knowledge improves with that. And some summary important information is like R square is given here. Then degree of freedom adjusted R square is there. F statistic is there. And its significance value is also there. So you read basic statistics. That is why I told you hypothesis testing. T distribution, F distribution, chi-square distribution. 3 distributions should be known to you. T distribution, students T distribution, chi-square distribution, F distribution should be known very well to you. Okay, basics of it, because they are very heavily used in econometrics. All right, now comes the answer whether this is econometrically good or not. You want to know that. So there is an option in this same screen on the top side, third one, you can see the option tests. So if you click on the option tests, it will show you different options, different kinds of tests that you can run. Now, given that it is cross-sectional data, the first fear that we have is about heteroscedasticity, correct? Given that it is cross-sectional data, the first fear that we have would be about heteroscedasticity. So in option before that, you know, whenever you run regression, something is left out known as residuals. Whenever you run regression, something is left out which you can't explain. For example, R square is 0.59 or 0.60 approximately. So 60% of variation in exam score, this exam score depend y variable, is explained by your model. That is all these variables that you have included. Still 40% is left out. So something is always left out or not explained. So what you can do is you can go to the option graphs. Okay, you can go to the option graphs and you can click the option, go to the option residual plot. Okay, go to the option graph in the screen that you can see, your result screen, OLS result screen, and then go to the option residual plot. And then here you can look at the residual plot against your y variable. Okay, against your y variable. Is there a systematic relation between what is left out and your main variable of interest? Let's say exam score is your main variable of interest. And once you do that and click on the option OK, it will create a graph or a chart. I'll shorten the screen. It's quite large actually. Let me make it smaller. I think Gretl is, there is some screen sharing issue going on with me. Only some portion of my screen is visible. So this kind of a chart is opened up, okay, and it shows how your residual, it's a scatter plot basically between your residuals and the y variable. And what we see is that there are two components. One component is here where there seems to be a slight upward moving relationship, but it's not very prominent. However, here there is a whole outlier component where there is quite strong evidence of increasing relation. So as your y variable exam score is increasing, the residual, the error in your model is also increasing. There is some issue in your model. Okay, there is some issue going on in your model, and it's a very long process to discuss about these things. We may not be able to discuss everything right now, but I'm giving you an overview. These are the things you can do. Go back to your results, your main model window, and go to the option test. Okay, your main model window and go to the option tests, and then you can check for normality of your residuals. And if you press the option OK, it will, I'll share that new screen, result screen with you. So it is completely visible. Yeah. I hope you can see the screen properly. Yeah. So you can press this test. It will show you a histogram, but you don't need to see the histogram. You can see the test result also. It will give you test result also. Just a moment. Yeah. So this kind of screen will be visible. This I've opened in front of you. It will test the normality of your residual. And here what we are primarily interested in is at the bottom. At the bottom, there is a test conducted, okay, a chi-square test conducted for the residuals. The null hypothesis is that it is a normal distribution. So if you reject the null, okay, which is what is occurring, because firstly your chi-square, your test statistic is very large, 57323, and the p-value is very small, 0. So it won't be 0, it won't be 0.0000, then some 0, and then maybe 1 or some value, but it will be very negligible. So you are strongly rejecting the null. What is the null? That it is a normal distribution. So your residuals are not normal in this case. Okay, so this is something you need to look and take into account, that your data residuals are not normal. Okay, so these are the things you can do. You can store this result also in Gretl. You can save the files in Gretl, save this model also in Gretl. You can do a lot of such stuff in Gretl. And there's another file I want to show, because there's time series data and a lot of dimensions of time series data are there. I request Dr. Jaskaran and the organizers, 10-12 minutes extra will be required. Okay, so kindly bear with me. Okay, 10 to 12 minutes extra will be required to finish the session to show. So I'm closing the screen, and now what we will do is, we have looked at the cross-section methods of econometrics. What all you do, starting with importing the data, looking at its structure, dealing with its sample size, changing the sample size if you require it, looking at descriptive statistics, looking at correlation, creating the heat map of correlation matrix, and then going for regression analysis, OLS in specifically a very important econometric method. We also saw there are so many other options in Gretl other than OLS. Then we ran the OLS regression, saw its result. Results are important, but then what is important is whether the results are clean and free of any kind of error. Okay, so last thing that you can do here, again I'll share that regression result screen with you. Last important thing that you would like to see, again you can go to the option in this regression result window, you can go to the option analysis, and here you can see the option collinearity, that is multi-collinearity can be tested for. Okay, this could also be a major concern for you. So in the main regression window, analysis, and then collinearity. Once you click that option, a new window will open. Okay, a new window will open with collinearity results, which will report the variance inflation factors. Okay, variance inflation factors are one way or a major way of looking at whether there is any kind of severe collinearity in your data or not. And if some variables, if their correlations are ballooning or expanding their variances beyond manageable proportion, which is generally greater than 10, many people consider it greater than 5 also to be a problem. Gretl says greater than 10, but generally I've seen greater than 5 also people treat it as problem. So you have to research and study about multicollinearity, you know, to be able to make sense of it. But here it is almost 1, not even greater than 5, less than 5. So you can be safe that even though there is some correlation between some variables, it is not creating any kind of problem for your data set, your regression results. So you don't need to worry about it per se. All right, now we'll go on the second file, because it's a time series file. Many of you might be interested in time series data also. Okay, it has its own properties and its own behavior. So I'll go back to the main Gretl window. Okay, and in this Gretl, this last part of my session, we'll go back to the main Gretl window and we'll go to the option file. Again, now you know everything. I won't spend more time on this file. Open data, user file, I'll find out the second one, dataset 2 file, which I have shared you 2 Excel files in WhatsApp group. I'll take the dataset 2 file and I'll press open. Okay, it is asking me whether if you want to open a new data file, do you want to close the current one? Because if you do, all your work will be deleted. I'll say yes, no problem. Now, once I do that, there are 2 files, 2 sheets in this data file, Excel file, simulation and explanation. Explanation is just about the variables. I hope you people checked it, very important. Okay, I have explained all the variables there. What is output, what is labor, how it is defined, what is the source, measurement unit, everything I have explained there, which is what I have done in my Routledge book also. So you go on this first one, simulation data set, and you press OK. So once you press OK, Gretl has automatically recognized that it is time series data. And how? You can see on the bottom one, it is saying annual. Earlier it was saying undated. Now it is saying annual. And what is the yearly range? It is annual data. So yearly data, what is the range from year 2000 to year 2021? So it is 21 years of data. Correct? 22, I guess, if you include 2000 also. So 2000 plus 21 is 2021. That 2000 plus that 2000 itself will become 22nd. So there are 22 years of data in this data file. I have taken a shorter data for our analysis. And now this is time series data. And we have 3 variables. The first variable is output. So whenever you're running a company or running a country or wherever something is being created, inputs are used and output is produced. So input is labor, lab, LAB, and capital, machinery and technology. And I have done this for banking sector. This data is for banking industry. Okay, specifically India. I have taken it for Brazil, Russia, India, China, all 4. But here it's about, I have taken it for Brazil, Russia, Indonesia, India, China, and South Africa, all 6 BRICS economies. This is only for India. So there is labor, data on labor, LAB. There is data on capital, okay, which I have defined as number of branches as fixed capital. And you take labor and capital together and you can create output. What is the output variable with us? If you double click, it will open that output data or output variable. It will open a new screen. So those who are running the hands-on, you can just double click on the output variable. It will create a new screen, open a new screen where it will show you the values of output variable. Okay. So what is this output variable? This is the amount of deposits, amount of loans generated. You can check that Excel sheet. I have given explanation. Either deposit or loans, any one would be there. So it is either the amount of loans that the banks have generated, and to generate loans, produce loans, okay, banks require labor and capital. I hope you got the idea. You take labor and capital, mix them in a particular year. In that year, you will have loans generated. Next year, again, mix labor and capital. Okay, you can create loans or deposits, whatever is your final product for the customers and for the country as a whole. Now, in this, again, you can run the same things, correlation matrix. And then there is there are 3 more files, outputs STD, labor STD, and capital STD. That is basically standardized variables. In regression, you can't compare the size of the coefficients directly because your let's say labor is in the labor variable is in terms of number of people. Okay, capital is in rupees crore. So you can't see you can compare the effect of labor on output with capital on output directly, because the measurement unit of labor is different, capital is different. So their coefficient, regression coefficient cannot be directly compared. You can compare the sign, one is positive, one is negative. That is fine, absolutely fine. The size cannot be compared. In order to be able to compare the size, which one is more important, labor or capital? For banking sector's output, you need to standardize the variable. That is one way. How do you do that? If you want to standardize a variable, what is standardization? In standardization, you adjust your variable data for its mean and standard deviation value. So you remove the mean and divide it by standard deviation. So how do you do that in Gretl? You don't need to do it manually. You can just go to the option add. Okay, you can just go to the option add, and here in the middle you will have a variable option called standardize selected variables. Okay, standardized selected variables. And once you click that, so you have to go to the option add, then option standardize the selected variable, or you can do one thing, you can select all three together manually, then go to the option add and press standardize selected variables. Then you will have three options: divide by sample standard deviation without degree of freedom correction, or center only. In center only, it will only subtract mean, it will not divide by standard deviation. Once it does that, once you subtract mean and divide by standard deviation, the measurement unit is changed. Okay, and it becomes a single measurement unit. Okay, so now the scale is collapsed from whatever measurement unit you had to a standard scale. So everything can be compared, and the regression coefficients will also be comparable now. All right, I'll just add the standardized variable once. Once I do that, three more variables are added, and the description is also given: standardized output, standardized labor, standardized capital. Now you can do correlation analysis, descriptive statistics. I've already shown you, I'll not repeat that. But a very important aspect of time series data are unit root. If your data are not stationary, problems can be faced. So to test that, you have to do it for each variable. You can't do it together for all variables in Gretl. Select whichever variable, just go to the option variable. Just go to the option variable here on the top right side before the option model variable. Okay, go to the option variable, and then you will have the option unit root tests. Okay, unit root tests, and then you click the option. Now in unit root test, you have different ways of doing it. Nowadays the trend is that if you are doing time series, dealing with any kind of time series data, whether it is in management, economics, sociology, or political science, whatever social science subject, business studies, at least 2 to 3 stationarity test results should be reported. I'm not saying it's compulsory, but it would be good for you. So use ADF, use KPSS, and also use Phillips parent test, for example. I prefer that ADF, KPSS, and Phillips parent. And the result across all tests should show that your variables are not stationary. That is, they do not have a unit root. If that is the case, then your results are very reliable, and it improves your chance of, reduces your chance of desk rejection. It may not improve your chance of being accepted, but at least it may not be rejected on the desk by the editor. I've learned all this after getting a lot of rejections. All right. So unit root, and press the option ADF, the standard test that we generally use, augmented Dickey-Fuller test. Now, because this is annual data, I don't need to go up to 8 lakh. That's foolish. 1 lakh is more than enough for me. All right. 1 lakh is more than enough for me. Beyond that, there is no meaning in investigating non-stationarity in your data for annual data. If it is quarterly, up to 4 lakh. Okay. If it is 6 monthly, up to 2 lakh. So depending on the frequency, you have to change the lag order for your ADF test, and let other options remain the same. Don't change them. At the bottom, there is an option: use level variable or first difference. Choose the first one. Let the first one be there. Use level variable, and then press OK. Once you press OK, a new window will be provided by Gretl. It will look like this. I've just shared it. In a moment, you will be able to see. A new window will be opened up. Augmented Dickey-Fuller test for which variable? Output variable. What are you testing? You are testing it for 1 lakh. And which criterion are you using for lag selection? Generally, see, we have in that test option, we asked Gretl to start from the highest lag that it feels is important, and then go to the lag that we want. So how did it decide to go from higher lag to 1 lag? AIC, Akaik information criteria. You read things about it and you'll be able to study. We'll have a separate workshop on time series econometrics soon. So you will be able to learn about it. JKEA, Cafe Economics will come together to create a separate workshop on time series econometrics, all 7, 8 days, 10 days. So in this result, you can see the test statistic here, tau, this test statistic. What you want to directly see is the p-value. If p-value is so high, the null hypothesis. What is the null hypothesis here? Null is a = 1. That is, there is a unit root. So it is assuming there is a unit root in your data. If you can reject that assumption, then there is no unit root and you are not suffering a non-stationarity issue, at least at this level. But if there is a unit root, you cannot reject the null, and unfortunately the p-value is very clear that you cannot reject the null. It is very high. So the null hypothesis, there is not enough evidence to reject the null hypothesis. What is the null hypothesis? That there is a unit root, a equals 1. So in this case, you have to accept the fact that there is non-stationarity in your data. It is very common in time series data. So you go for differencing it, you can take ratio of it, percentage change in it, you can take first difference, you can take logarithmic value, log, natural log, and then take its first difference. There are a lot of ways to deal with it. It depends on what kind of data you have. Generally, first difference is preferred. I prefer log difference because converting data into log firstly suppresses that any kind of heteroscedasticity that may be there in the data, maybe, and then taking first difference of log gives me a rough measure of the growth rate in the variable, and log difference becomes very easy to interpret also in terms of regression coefficients. All right, so I close this and quickly I'll show you now the last part of my session. I'll show you the time series options that Gretl provides. What can you do with time series data in Gretl? You can do a lot of stuff. You go to the main window and go to the option model, correct? We go to the option model. I'll remove this screen here. Yeah, we go to the option model, and there you can see univariate time series option, where you can analyze time series variables not only between relation between themselves, but how they themselves affect past values, how their past values also affect their future current values. That kind of dynamism and relationships can also be introduced in Gretl, such as ARIMA, and then Garch, where if you are interested in volatility, like you are analyzing stock market index, so some kind of auto-regressive conditional heteroscedasticity model would be used. Arch or Garch, Parch models are there, eGarch, eParch are there. A lot of options are available. Yeah. Then you have multivariate time series options available, where you can allow variables to have dynamic feedback effects, interrelations with each other, like co-integration, VAR, vector autoregression, VECM, vector error correction models, structural VARs, which I prominently use in my time series work. These are the things you can use in Gretl. And you go to the first option, ordinary least square. Okay, once you press ordinary least square, it will open a option or dialog window. Okay, like this. I've just shared it. Session is about to end. 2-3 maximum 3-4 minutes, 5 minutes. Dr. Jaskaran. So you click this option and you select the first variable. Now, of course, it is non-stationary. I am not doing anything for. I've shown you how to test for it. Then you modify it, take first difference or take growth rate form. Again, do the same thing: variable, unit root, ADF test. See whether now it is finally stationary or not. Once it is, then you run this regression. But I'm not doing all that due to lack of time. I'm directly going on the main variables, and I'm choosing the option out. I go to the option model, click on the option first one, ordinary least square. This window will open that you can see on your screen. Take the option output, press this blue button. So output will move on the dependent variable side. So you are saying Gretl that your y variable, dependent variable, is output. And what are your x variables or regressors? Your x variables are labor and capital. I bring them on the right side. Constant is always going to be there. We generally don't remove that, and you shouldn't unless there is very strong reason. Unless you are regressing through the mean, those kind of situations come, don't remove the constant. And then press the button OK. And once you press OK, another MacBook, you have to download, the person who is asking Ankur, you have to download Gretl for MacBook. There is a separate, you just Google Gretl MacBook and it will have another option. Yeah. So about to end now, Dr. Jaskaran, 1 or 2 minutes more. So this is the screen that you will see once you have that regression result, and you can see the coefficient for variable labor, variable capital. You can see R square here quite high. Of course, trend will be there. So in time series, high R squares are quite common. Once you make them stationary, take first difference, other things, then you will see R square is reduced. Durbin-Watson statistic is there, but so in time series, what are the diagnostics you would like to check? You go to the option tests in this model window itself. You go to the option tests and you can see the various options. Primarily, we would be interested in autocorrelation first. That's the first concern in time series variable. Okay, before that, what you should do, you should go to the residual graph. So go to the option graph, go to the option graph in that result, residual plot, go to the option graph, residual plot, and you can see the residual plot against your variable y output. And once you press, a graph will open, and clearly what I can see is there is no linear relation between residuals and your y variable, that is output, but there is some form of non-linear relationship visible, correct? There is some form of non-linear relationship clearly visible. Okay, so there could be, but linear relationship is not there, so you can be on a little safer side on this end. On this end you can be on a safer side. Again, you can go to that Gretl model itself, correct? There's so much open in front of my screen. Yeah, you can go to the Gretl model itself and go to the option tests and check for autocorrelation. Go to the option test, and then on the middle end you will have autocorrelation option. Then you can test for lag length, generally being annual data up to one order. First order autocorrelation is what we are primarily worried about. So lag order is kept 1, and you press OK. Once you press OK, you have another window. Okay, once you press OK, another window. It looks like this. The Broish-Godfrey test is by default conducted by Gretl, and in this test, forget about all of the things above. The test statistic is what you need to see, and if you see the test statistic, okay, whether there is first order autocorrelation or not, it is rejecting it. So there is now this is very important to remember whenever you conduct any test, okay, in Gretl or in any software, always go for checking whether, always go for checking what is the null hypothesis. Okay, what is the null hypothesis of that particular test? If you don't know the null hypothesis, your interpretation will go wrong. So the null hypothesis of this test is that there is no autocorrelation. Okay, there is no autocorrelation. Your data is fine. But if you see the results, okay, if you see the results, it is quite evident that the null hypothesis is rejected because the p-value is quite small, less than 5%. Okay, less than 0.05. So that means there is evidence that there is first order autocorrelation in your data. So perhaps you can explore different time series models like ARIMA or other variants, or maybe you can correct autocorrelation. I'll share some very good books on econometrics. Read what can be done when autocorrelation is present in your data. And I think with this, I would end my session. And I have given you a brief overview of cross-sectional data, time series data, how both are used, put them in Gretl, what different things you can do, what kind of regression framework you can run, how do you test for various diagnostics. And this can be a good beginning for you to go forward. Dr. Jaskaran, I hereby hand over the session to you, sir.
Thank you, Professor Baria. Really, it was very insightful and cheerful session. Like, I hope that all of the participants were following you. Like, they were learning by doing.
Yes, sir. I
Like,
also hope so.
yes. I think there are 1, 2 queries in the chat box, and if somebody want to ask any question directly from Professor Baria, and participant can ask anybody.
Hi, sir. Good evening.
Hello.
Hi, sir. Good evening. I'm Ankita from Punjab. Your lecture, I really appreciate your lecture. It was really informative. So I directly come to my question. My question to you is that in social sciences, mostly relationship between the variable is bidirectional. Like, so it becomes difficult to differentiate between cause and effect relation. Sometimes cause will become effect, and similarly, the effect become the cause. For example, if I take an example, in case of education and income, if we say that there is direct relation between education and income, so if we have a good education, then we have a good income. But vice versa is also true. If we have a good income, if we have a decent income, then we can afford the good education. So in such a case, how we can differentiate between the cause and effect relation, like how we can determine the causality in such a case?
This is a very nice question, and perhaps one of the most complex questions in econometrics, because a lot of literature has been developed on this. The first thing comes that you investigate your literature further before getting into econometrics. Go deeper into your literature and see what majority of the evidence suggests. That is what route that you can adopt. That is one practical way to start. The second thing that you can do to find out if you believe that there is two-way causality in your data set, and if you have time series data, you can take advantage of that two-way causality, and you can go for multivariate time series regression models like vector auto regression or vector error correction models, which can handle two-way causality problem. All right, they can very well handle two-way causality problem. That should not be a problem. Third thing that you can do is maybe in current period, as of now, in current period, two variables are causing each other. But if you take one variable's past and link it, regress it on another variable's current, then causality would be very clear. So let's say x and y are both affecting each other as of now. But if you take past of x and put it on y, naturally x has to come first and y will come second. So there you can dodge the problem of two-way causality. If you are ideally, you should go for multivariate regression frame, time series or econometric models like VAR or VECM. But if this is the if you don't want to get into such detailed approaches, going into literature, looking at what is the majority of the literature saying, following that, or then if your time series data, change the time dimension, take lagged value of one of the variables and affect it on the current value of a particular variable. And suppose if there is cross-sectional data where there is no time series option available, structural econometric models can be investigated. You can contact me further to know about it. In structural econometric models, you can create more dynamic, more interdependencies and allow variables to affect each other and take advantage of that. For example, simultaneous equation models are a very powerful tool. Very few people in India actually use it. I am also trying to learn it, very complex, but you can handle that also. These are 3-4 practical ways I can suggest you to handle it. And you can contact me more if you want to solution for a specific problem.
Thank you so much.
Yeah.
Anybody else? I think everything clear to all of them, all the participants. Professor Baria, I have also a query.
Yeah.
Like, if we have to say the Gretl's edge over SPSS, like one thing I find that it is very quick. It is providing very quick results. Like, second thing that you didn't define the variables when you are interpreting and feeding the variables from uh, transporting from
Excel.
from Excel, then you didn't do that exercise. If you want to say on this something like
Yeah, but
differently.
so, with regards to SPSS, it's a personal choice. I mean, which one you prefer. Gretl has capabilities like if you want more advanced econometric models or you want more detailed, deeper results of those econometric models, Gretl will be much better option, and it's free of cost. So, why to spend so much of money on a premium software like XPSS? With
Yes.
regards
This is free
to
of cost.
it's free of cost. It's a great advantage of this.
Yes.
And secondly, with regards to defining variable, I'm not getting it. See, Gretl recognizes the name of the variable and the values, and it links
Yes.
those values with that name. Other
Yes.
than that, what do you mean when you say define the variable? I mean, do you want me to
Like
tell?
like in SPSS, sometime we classify the variable that like caste, class, and sometimes there are discrete series like income and yes,
Acha, I got it. So you can create dummy variables in
yes,
Excel.
yes,
So suppose if you
yes,
have, I have that kind of data set also. Let's you say you have a variable which is on male and female. Male,
yes,
female, male,
yes,
female,
yeah,
female, male is written. So you
yes,
can
yes,
load that data into Excel and then
yes,
click that option and go to the option add variable.
uh,
Go to the option variable. Okay, I'll just share that screen if you allow me. Quickly, I'll show you in 1 minute. I'll show you. So you can go to this main Gretl screen, and here you can go to the option variable. All right,
yeah,
and in this particular variable, not variable, you can go to the option add. Sorry, go to the option add. Okay, and there on the bottom end you will have option for creating dummies, observation range dummies, or dummies for discrete variable. So if your data is discrete and let's say it has
yes,
only let's two value, you can define, you can take this option observation range dummy, or the second one dummies for discrete variable, and you can specify male equals 1. So what Gretl will do, it will convert all male values as 1 and all other values as 0, and you will have a dummy variable in front of you. You can do that for caste, for area of location, uh, religion, whatever you want to do that. That's very much possible in
have to
Gradle.
do manually.
Yeah,
Okay,
you can just click on
yeah,
this. You can just
okay, yeah,
you don't need to manually make it 1 and 0. You just click
yes,
on that
oh,
option. Tell zero
oh, yes,
Gradle what is 1.
yes,
Just tell
yeah,
it what is 1. It will convert all those into 1 and remaining into 0.
okay, yes.
I'll stop
I
sharing the
think,
screen.
okay, I think nobody want to ask more question, and I think anybody interested to ask
Yeah,
something?
somebody is asked what is the basic book for econometrics for
Yes,
beginners.
yes, yes,
I'll Gauhar has asked it. I will be sharing those books with you, 2 3 books. So don't worry, I'll be sharing good books with all of you.
yes. As you were also suggesting that for expertise, all of us we have to do practice. And Professor Baria, if you could tell us about some data sets where we can find the data sets for doing practice, like
Yeah, that
on.
also Gretl also solves that problem. So if you go to Gretl, let me share that Gretl screen with you again. And if you go to uh, Gretl main window and go to the option uh, file, and then you go to the option user file. Okay, you can click on this in file, open data. Instead of user file, you can go for the option sample file. And if you click on that sample file option, a new screen will open, which I am now going to share with you. A new screen gets opened up, and there are 3 major sources. Gretl's own internal data set. You can see how many large number of data sets are available, and you have cross-sectional data, time series data, and panel data. All kinds of data are available. And then
It's interesting.
it's interesting. And then Robert Greene's book is there. That Green book
Okay,
actual data set is available, and Ramanathan's books data set are also available. And
really
you can
great.
also, yeah, it's a huge. And then
Yeah.
you can go on this on the top. There is one option, look on server, and you can click on that. And once you click on that, another screen will open up. Another screen will open up. I'm now sharing that new screen with you, and then in that there are huge number of econometrics textbooks whose actual data sets can be imported right away into Gradle. So, I mean, there is almost
It
infinite
means
data.
we have many things to learn.
I
Yes,
mean, you can keep working, and
yes.
you
And
can practice.
Gujarati is also here,
Yeah, Gujarati
and
book is also
it's also
exactly,
here. Yeah, we can
exactly.
do
All major
practice.
textbooks, all major
Mhm.
textbooks are there.
Sir,
So that
one
is,
question, sir.
yeah, please tell.
Sir, earlier you were telling that there will be a separate classes for only on econometrics model. So
Correct.
when can we anticipate or expect that, sir?
I would be happy to do it very soon. I'm sure Dr. Malik and myself and our team will sit together and discuss. Even though I cannot officially comment or commit you right now, maybe I hope in next 1 month or so we should be able to, if everything falls into place, Jammu and Kashmir Economic Association and Cafe Economics and our other partners and even maybe new partners may come together to create a very wonderful econometric modeling workshop. Month maybe minimum, at minimum, bare minimum.
Yeah, waiting, sir.
Yeah, great. Thank you.
It's interesting, Professor Varia. You are finding students like the learner who want to grasp econometrics.
Yeah,
It's nice. It's nice.
thank you.
And in the end,
Hello,
on the
good
behalf
evening,
of
sir.
yes, yes,
Yeah, go ahead.
yes, you can ask. Yeah.
Last question. Go ahead.
Good evening, sir.
Yeah, good.
Sir, actually, my question is not related to today's session. Sir, I have some query, can I say that?
Yeah.
If you allow me for that.
Yeah, please go ahead.
Sir, currently I'm PhD scholar,
Oh.
working on emerging economies. Sir, I want to know where I can collect literature for my research. And also, when conducting a literature review, what prompt should I use to gather relevant and comprehensive information?
Now that question is very specific to your topic, so let's not engage everybody. Just WhatsApp me and get back to me. I'll help you out.
Okay.
Don't worry. I will surely help
Oh.
you.
Okay, thanks a lot, sir.
All right,
I
Dr.
think
Jaskaran, sir.
yes. I
Tell me,
think
tell me.
in earlier lecture you explained this thing in a good way.
Yeah,
When you
I
are
did.
conceptualizing the research, I think in that
Research
day you have
topic, yeah.
explained this thing. Yes. Okay. On the behalf of organizer, I would like to extend thanks to Professor Bhagirath Baria. Sir, it was really very like a practical session. We have learned a lot, and the way you explained the econometric while using Gretl, it was interesting. In fact, I was also doing here while you were
That is
explaining.
so
I
nice.
think
That is so
yes,
nice.
I was also doing, and it was very interesting. In fact, when you were explaining the theory of econometrics from the beginning, and you are relating the theory with in the practice, like you were explaining, and it was really interesting. And thank you. I think now it is 8:30 already, and I think thank you. Now over to Professor Firdaus, if he is here.
Thank you very much. It was, wonderful session as always from Dr. Bhagirath.
Thank you,
Actually,
Firdaus,
I
sir.
am outside now. I will request all the participants. Some are asking about recording and all. Everything has been put on our YouTube channel. But unfortunately, you people neither like the videos nor you are subscribing. We are having almost 250, participants. So the lectures are there free of cost. Go visit, save them, like, share with your students, share with your co-fellows. This was all from my side. It is already late. So let us meet tomorrow with new learning and new discussion. Thank you very much.
Great.
So you
Last
can
thing,
now leave the session. Yes.
for those last thing, everything is being provided freely, and yes, it is duty of all of us that at least we should follow Jammu
Correct.
and Kashmir Economic Association's video
We
on
should.
YouTube. I think we can do it.
Definitely.
Uh-huh. Thank
All
you.
right. Bye-bye.
Thank you.
लगा। इसे अमेरिकी स्टॉक मार्केट इतिहास का सबसे बड़ा नुकसान माना जा रहा है। यानी आर्थिक से लेकर